In the vastness of the universe, the speed of light is not just a concept from science fiction. It is the key to unraveling the mysteries far beyond our solar system. Imagine a world where journeys to distant galaxies are not only possible, but a reality. NASA, the world's most advanced space agency, recently revealed something that could change the course of space exploration forever. Stay tuned as we dive into 10 groundbreaking facts about NASA's ambitious plans to achieve what once seemed unattainable, light-speed travel, through revolutionary futuristic technologies. But before we get started, be sure to like this video and subscribe to the channel. 1. The vastness of space and the need for advanced propulsion. The size of our universe is almost beyond comprehension. It is a vastness that can be both awe-inspiring and terrifying. NASA, a pioneering force in space exploration, understands this challenge better than most. As it peers into the abyss of space, the agency acknowledges the enormous distances that separate us from even our nearest stellar neighbors. To grasp these immense distances, we first need to introduce the concept of a light year. A light year, contrary to what the name might suggest, is not a measure of time, but of distance. It represents how far light, the fastest thing in the known universe, travels in a year, about 588 trillion miles. When we say that our nearest star, Proxima Centauri, is about 4.2 light-years away, we are saying that, traveling at the speed of light, it would take 4.2 years to reach it. But here's the unfortunate reality. Even with the fastest spacecraft we've built so far, like the Parker Solar Probe, which travels at approximately 30,000 miles per hour, it would take thousands of years to reach Proxima Centauri. This brings us to a pressing challenge: improving our methods of propulsion. The inefficiency of current technologies becomes clear when we look at the prospect of interstellar travel. Traditional propulsion systems, primarily based on chemical reactions, lack the power and sustainability required to send a spacecraft to even the closest stars within a human lifetime. It's like trying to reach a destination thousands of miles away with a vehicle that can only crawl inches per hour. A major leap in propulsion technology isn't just desirable, it's an absolute necessity for exploring beyond our solar system. When NASA looks at the vast and daunting landscape of space, it doesn't feel intimidated, but rather inspired to think beyond, innovate, and dream of a future where these distances become gateways, not barriers, to a future where space is not an isolating void, but a region waiting to be explored. With NASA's recent revelation of a technology so advanced that it might achieve light-speed travel, we could be on the brink of turning this dream into reality. 2. The helical engine, a potential game-changer. The dream of deep space exploration has fascinated humanity for generations. As NASA has pushed the boundaries of human knowledge and technology, the concept of the helical engine has emerged as a promising path toward realizing that dream. But what exactly is this groundbreaking invention? Essentially, the helical engine harnesses the process of mass variation that occurs at speeds approaching the speed of light. Imagine a giant box in space. Inside this box, a weight connected by springs bounces back and forth in the vacuum. As the weight moves in one direction, it gains a slight increase in mass due to Einstein's special relativity. When it reaches the end and bounces back, it does so with its original mass. This continuous change in mass generates thrust, similar to how a submarine uses propellers to move through water. While the concept sounds simple on the surface, it could lead to significant propulsion if applied correctly. The mastermind behind this revolutionary idea is David Burns, a NASA engineer. With a deep understanding of the complexities of space travel and the challenges it presents, Burns proposed this engine as a theoretical solution to achieve almost unimaginable speeds in space. According to his vision, given the right conditions, enough time, and a suitable energy source, the helical engine could potentially propel a spacecraft to speeds nearing 99% of the speed of light. That's nearly 670 million miles per hour. Though it may seem like something out of a science fiction story, the helical engine suggests a plausible future for space travel. Achieving such speeds could revolutionize how we explore the cosmos, turning interstellar travel into a tangible reality in the not-too-distant future. 3. A deep dive into the technical aspects of the helical engine. One of the most fascinating breakthroughs NASA has proposed in the race toward light-speed travel is the concept of the helical engine. At its core, the engine operates based on principles that may seem like a complex physical dance. However, when broken down, it resembles a box in a vacuum with a weight inside. Within this box, The weight moves continuously back and forth, connected to something similar to a spring. This constant motion, along with the mass-altering processes that occur at near-light speeds, allows the helical engine to generate thrust using the principles of special relativity. The size and power consumption of the helical engine are nothing short of monumental. It isn't something that could easily fit inside a conventional spacecraft. In fact, it would need to be enormous, measuring over 656 feet 200 meters in length and about 39 feet 12 meters in diameter. The energy demand is equally immense. For the helical engine to achieve practical speeds, it would require an astounding amount of electricity, around 165 megawatts. To put that into perspective, that's enough power to supply a small city. Given such high energy and size requirements, one might wonder, where could this engine be most effective? The answer lies in the vast expanse of space. In these regions, free from air resistance and other earthly limitations, the helical engine could truly demonstrate its potential. On Earth, the atmosphere and gravitational pull inhibit its functionality, but out there, among the stars, the helical engine could well be our key to exploring the farthest reaches of the universe. 4. Previous attempts. The M drive. In its relentless pursuit of space exploration, NASA has often been at the forefront of developing innovative technologies, one of which is the M drive, a revolutionary propulsion system. The M drive stands out not only for its groundbreaking concept, but also for the debates and controversies it has sparked within the scientific community. The operating principle of the M drive is fascinating. Instead of relying on traditional fuel-based or exhaust-based propulsion methods, the M drive works with a unique mechanism, reflecting microwaves inside a sealed chamber. This process, though seemingly simple, generates a significant amount of force, providing the necessary thrust for propulsion. The implications are enormous. It offers a propulsion system that doesn't require large amounts of fuel or the heavy weight such fuel typically adds to a spacecraft. However, the M drive has its skeptics. One of the primary challenges this innovation faces is the immense heat it generates. Managing and dissipating this heat is crucial, especially in the cold vacuum of space, where no external medium is available to assist with cooling. Skepticism goes beyond practical concerns. The way the M drive functions appears to defy the laws of physics, particularly Newton's third law, which states that for every action, there is an equal and opposite reaction. How could it generate thrust without producing any reaction in the opposite direction? While the M drive has ignited hopes for a futuristic propulsion system that could redefine space travel, the scientific community remains divided over its feasibility. The next steps for this technology involve rigorous testing and validation, potentially requiring us to rethink some of what we know about the physics of propulsion. Regardless of the outcome, the M drive undeniably reflects NASA's bold spirit and commitment to pushing the boundaries of what is possible. 5. Alpha Centauri, humanity's next frontier. Alpha Centauri, often regarded as the closest stellar system to ours, symbolizes the possibilities of space exploration and serves as a testament to the enormity of our universe. Located just over 4.2 light-years away from Earth, this system is not only close in cosmic terms, but also holds the promise of undiscovered worlds and unsolved mysteries. One such enigma that has captured the imagination of astronomers and space enthusiasts alike is Proxima b. Its discovery marks a significant milestone in our understanding of celestial bodies, representing much more than just another trophy in the history of space exploration. It could be a potential second home for humanity. Situated in the habitable zone of its parent star, Proxima Centauri, Proxima b holds the potential to harbor life-friendly conditions. This possibility elevates the significance of this exoplanet beyond mere curiosity. It has become a symbol of hope, offering a tantalizing suggestion that we may not be alone in this vast universe. Recognizing the promise and intrigue surrounding Proxima b, NASA has unveiled plans that, a decade ago, might have seemed audacious. By 2069, NASA aims to launch a robotic spacecraft to Alpha Centauri. However, this is no ordinary exploratory mission. It is an interstellar journey on a scale humanity has never attempted before. Such an endeavor showcases NASA's unyielding spirit of exploration and its determination to push the boundaries of what is possible. Traveling to a star system light years away and potentially uncovering the secrets of a distant world that may resemble our own is a challenge NASA is eager to embrace. Through this mission, NASA is not just reaching for the stars, It seeks to redefine our understanding of space-time and our place in the universe. 6. Alternative propulsion, the solar sail. In the vast realm of interstellar exploration, where distances are so immense that even light takes years to travel, conventional rockets cannot address the challenges we face. However, hope lies in innovative technologies such as the solar sail. This is not your typical propulsion method. Instead of burning fuel, the solar sail harnesses the power of photons, the tiny energy particles emitted by the sun. It's similar to a sailboat harnessing the wind, but in this case, the spacecraft captures sunlight. One prominent figure behind this ambitious endeavor is Yuri Milner. His groundbreaking Starshot initiative proposes a radical shift in space propulsion. Rather than relying solely on the sun's gentle push, Milner suggests boosting these sails with powerful Earth-based lasers. These lasers would focus intense beams of light onto the sail, delivering concentrated pulses of photons. This method could propel the sail to a fraction of the speed of light, dramatically reducing travel time to distant stars and their exoplanets. However, great innovations bring significant challenges. The extreme force exerted by the lasers on a structure as delicate as a sail demands that it be exceptionally resilient. It must withstand both the force and the extreme heat generated during the process. Imagine trying to capture a storm with a piece of paper. The sail must be strong yet flexible. Achieving this balance is no small feat. It requires a delicate interplay of physics, materials, science, and engineering. If successfully developed, this technology could herald a new era of space exploration. Imagine reaching nearby star systems within a human lifetime. It's an exciting prospect that reflects humanity's relentless pursuit of going beyond and breaking the boundaries of what is possible. 7. Alcubierre's theoretical warp drive and its implications. As space enthusiasts, we have long been captivated by the idea of faster-than-light travel, a concept often portrayed in science fiction. This is where Alcubierre's warp drive comes into play, a theoretical concept that could potentially transform these fictional stories into reality. Essentially, the warp drive does not accelerate the spacecraft itself, but instead contracts space in front of the ship and expands space behind it. This creates a bubble of normal space-time that moves faster than light, carrying the ship within it. The fascinating aspect here is that the ship does not move within the bubble. It is the space around it that moves. Theoretical physicist Miguel Alcubierre proposed this idea in the mid-1990s. Based on Einstein's general theory of relativity, which suggests that massive objects can distort the fabric of space-time, Alcubierre theorized that if we could manipulate this distortion, we could effectively move space. This movement of space-time would allow us to achieve seemingly faster-than-light speeds without violating any fundamental laws of physics. The original concept had certain limitations, particularly regarding the enormous amount of negative energy required. However, recent advances present a new model involving bubbles within space-time. These bubbles, rather than demanding an immense amount of negative energy, could be feasible with energy levels within our current technological reach. This revised model leverages the dynamics of space-time itself, possibly reducing the need for negative energy and making the use of a warp drive more practical than previously imagined. In essence, Alcubierre's warp drive and the new concept of space-time bubbles redefine our understanding of interstellar travel. It serves as a compelling reminder that the universe, with all its vastness and mysteries, may one day be within our reach, making the stars not so distant after all. 8. The current state of space travel speeds. In the vast expanse of our universe, humanity's efforts to traverse the interstellar void have been considerably limited by the capabilities of traditional rockets. While rockets have been essential in enabling us to explore our nearby space neighborhood, their usefulness decreases dramatically when we look beyond our solar system. The mechanisms that make rockets viable for lunar landings and sending robots to Mars are extremely inadequate for journeys to distant stars. Take, for example, the nearest star system to us, Alpha Centauri. It lies at a staggering distance of 4.2 light-years. Even if we launched a spacecraft at the speed of our fastest probes, such as Voyager 1, it would take more than 70,000 years to reach its destination. This is not merely a technical challenge, it is the harsh truth about our current technological limitations. To put it into perspective, 70,000 years ago, modern humans had only just begun migrating out of Africa. Can we really envision launching a mission that wouldn't arrive at its destination until an amount of time equivalent to all of human history had passed once more? Monumental travel times like these are not just the imagination of scientists. They emphasize a fundamental reality. With current propulsion technology, even the closest cosmic destinations remain entirely out of reach. Our most advanced rockets, which operate on combustion principles, cannot significantly shorten these long journeys. This limitation underscores the urgent need for breakthroughs in propulsion technologies if we are to seriously entertain the hope of becoming an interstellar species. The stars are out there, but with our current means of travel, they remain nothing more than distant, untouchable dreams. Therefore, the pursuit is not only about achieving higher speeds, but about reimagining the very concepts of how to travel through the cosmos. 9. Potential extraterrestrial life. The curiosity surrounding Proxima b. Proxima b remains one of the most fascinating topics in the vast expanse of the universe. Located just 4.2 light-years away from our solar system, this exoplanet orbits Proxima Centauri, one of the stars in the Alpha Centauri system. What makes Proxima b extraordinary is its position within the so-called habitable zone, often referred to as the Goldilocks zone. This is a region around a star where conditions might be just right, not too hot and not too cold, for liquid water to exist, a key ingredient for life as we know it. However, not all conditions are favorable for Proxima b. The exoplanet faces a significant challenge: exposure to high-energy radiation from its parent star. Proxima Centauri is a red dwarf, a type of star known for its volatile nature. These stars can emit powerful flares, bombarding Proxima b with intense radiation far stronger than what Earth receives from the Sun. These radiation levels pose a threat to any potential atmosphere Proxima b might have, potentially stripping it away over time and diminishing the chances of favorable conditions for life. Still, the universe often surprises us. While the radiation levels may seem discouraging, they don't completely rule out the possibility of life. On Earth, for example, life thrives in some of the most extreme environments, from deep-sea hydrothermal vents to radioactive zones. If Proxima b has developed protective mechanisms, or if life has evolved beneath its surface or in deep oceans, there could still be a thriving ecosystem adapted to these harsh conditions. In essence, despite the real and significant challenges, the intrigue surrounding Proxima b remains undiminished. It stands as a testament to the universe's potential to harbor life beyond our blue planet. 10. The future of interstellar travel. The vastness of space and the immense distances between stars are both awe-inspiring and daunting. One remarkable phenomenon that occurs as we approach the speed of light is time dilation. This relativistic effect means that, for travelers aboard a spacecraft moving near the speed of light, time would seem to pass normally. However, for those observing from a stationary point, such as Earth, much more time would have passed. In other words, a journey that feels like just a few years for the space travelers could correspond to decades, or even centuries, on Earth. This concept challenges our understanding of time and highlights the mind-bending nature of space travel. However, time dilation is only one of the many challenges of long-duration space missions. Extended space missions bring numerous logistical concerns. For example, how would astronauts replenish essential resources on such long journeys? Water, food, and oxygen would be critical, and current storage methods are insufficient for missions that might last decades. Additionally, the psychological impact of space travel must be taken into account. Isolation, confinement, and the profound effects of time dilation could have significant psychological consequences for the crew. Researchers are actively studying these issues, exploring innovative solutions, and delving into the human mind to prepare for such scenarios. At the heart of all these discussions lies one crucial element: propulsion. Our current propulsion methods, which rely primarily on rockets, are simply inadequate for interstellar travel. These immense distances require far more advanced propulsion systems capable of sustaining high speeds over long periods. Without such advancements, even reaching the nearest stars will remain an unattainable dream. However, with technologies like the helical engine and other innovative concepts on the horizon, the future of interstellar travel still holds promise. This challenge is a call to human creativity, intelligence, and our unrelenting desire to explore the cosmos. Thank you for watching. While you're still here, click on the next video to discover more amazing content. See you there.